So in this video, let's try to go through and look at how methylation and acetylation will affect the charges of lysine residues. And sort of first, let's look at how we're going to find the overall charge so that we can observe the change. Okay, so let's look here at this polypeptide I've drawn. It's lysine, alanine, lysine, valine. Now, we need to understand what groups exist on each one of these amino acids that contributes to the charge. We'll start with alanine because it's pretty simple. Alanine just has a hydrocarbon R group. It does not become protonated or deprotonated. It's just neutral. So I drew an X there because it's in the middle. There's no free carboxyl terminus and there's no free amino terminus. So it is not becoming charged or uncharged pretty much no matter what we do. Now this lysine, this first lysine is a bit special. It's on the end. So we're going to have the, so again we're talking about this specifically. We're going to have the R group, which is going to have an NH2 or NH3 on the end. You know that NH3 would be positive. And it'll, because it's on the left side, this is the amine side, so on this side, we'll also have the alpha nitrogen, and that'll also be NH2 or NH3. And we have pK values for both of these. So the pKn, the pK of the nitrogen group, the N terminus, the left side of the polypeptide chain, that's 9. And the pKr is 10.5. So the R group pKa, the actual R group of lysine, the special group that lysine has, is 10.5. At pH of 7, again, 7 means on a scale of 0 to 14, we are that strong. We are 7 strong, holding hydrogen towards us as the solution. The solution is that likely to retain hydrogen. So if we just look at the pKn, the pKa value of the N terminus of lysine, not the R group, the N terminus, 9 is greater than 7, so that means that that group is stronger. It's more likely to rip off that hydrogen and hold it. And that's exactly what it does. It's going to take the hydrogen from solution and it's going to exist in the NH3 form. So we have a plus 1. Now same thing, the pKr of so the pKa of the R group is 10.5. That is greater than 7. It is more basic than the medium. It is more strongly holding on to those hydrogens, so it is going to also be protonated. So that is NH3 plus. So plus 1. So we have a plus 1. So we have plus 2 so far. And we said that alanine does not have any groups contributing to pH. So alanine will contribute nothing. And then this lysine, now it's in the middle, so it doesn't have a free carboxyl, it does not have a free amine. It's right in the middle. All it has is its R group contributing. pK of the R group is 10.5 as we have listed here, and the pH of solution is 7. The R group is more basic than the solution. It holds hydrogen more strongly than the solution does, so it will be protonated and it will be in the NH3 plus form. So again, we get plus 1. Moving on to valine. Valine has a hydrocarbon tail. The R group does not contribute, and its amine terminus to the left of it is involved in a peptide bond, so it is not contributing, but it does have a free carboxyl group on the right side. So if we continue to draw this out, over here would be, basically this would be the COOH, right on the end, or O minus, and the pKa is 2.3. What's the pH of solution? 7. So pK of 2.3 means the carboxyl group isn't that strong, it's not holding on to the hydrogen that much, it's pretty stable without the hydrogen. Whereas the pH of solution is 7, there's a dearth of hydrogen in solution, so the hydrogen is going to be ripped off and it's going to go into solution, and this valine carboxyl terminus is going to exist in the COO minus state, and we just bring down that minus and we have minus 1. So what's the net charge? So we have plus 2 plus 0, so we have plus 2, plus 3, minus 1, so this is plus 2 overall. Plus 1, 2, 3, minus 1. So the charge of the polypeptide is plus 2 overall. So that's basically how you go about finding the pKa, or the charge of the polypeptide at a given pH. Let me see if I have covered the answer with my head. Okay, I have, so let me just draw this out to the side. So it would be plus 1, plus 0 from alanine, plus 1 from the other lysine, and minus 1 from the carboxyl group. And so this won't be making any sense. And let's see. Yes, so plus 1, plus 1, plus 1 is plus 3, minus 1, plus 0, we get plus 2 overall charge. So sorry about that. It's sometimes confusing to manage the screen here. At any rate, I hope that made sense. I'm going to cut the video here, and then I'm going to go into acetylation and methylation using this same example. So if you're interested in learning about how to manage that and how that affects the overall charge, please watch the next video. I hope that helped, and if you have any questions, please let me know.